So hello everyone. So in this video we will be seeing how we can use recursion and what is recursion. Okay, so recursion is actually calling a function from within. Okay, so it helps to perform repetitive tasks just like this, for example. Okay, so we will go through this. So we call the function again within itself and break the task into smaller parts. Okay, so what is it? The process in which the function calls itself directly or indirectly is called recursion. Okay, so let's see how it works. Hash include IOStream using namespace. So these are the headers. This is the main function. Here we have return 0. So this is the main structure. Okay, so very basic structure where from here we will call the function. Okay, so our recursive function in this case will be factorial. Okay, so int factorial. Okay, so this is the function and we will be passing a number. Okay, so what is factorial? Factorial, if you notice, is let's say when we say 5 factorial, what does it mean? It means 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, so the result will be 120. Okay, so this is 5 factorial. What will be 4 factorial? 4 factorial will be 4 multiplied by 3 multiplied by 2 multiplied by 1. This will be 24. Okay, so something like this. So how do we achieve this? This can be achieved using loop also. Okay, but we will be learning this how we can achieve this using recursion. Okay, we are calling a function from within itself. So if n equals 1, okay, n equals 1 or n equals 0, we will give return 1. Else what we will have? Okay, so let's remove bracket. Why? Because it's one single line. So if we use one single line of code inside, then I think brackets are not required, so you can remove that. So return. Okay, so what it will return? It will return n multiplied by factorial of n minus 1. So when we say this, what it will do is n, okay, and then it will call the function again and pass the same thing. In this case it will be n minus 1. Okay, so what will happen is, if you come in this picture, what is happening is factorial 5. So this time return 5 multiplied by factorial 4. Okay, so again this is getting called, so this function is getting called, and 4, so 4 will again return 4 multiplied by n minus 1, which is 3, so factorial 3. Okay, so now again factorial 3 will get called, so 3 multiplied by, now n is 3. Okay, so n, which is 3, multiplied by factorial of n minus 1, which is 2. Okay, now again it will get called, so 2 multiplied by factorial of n minus 1, which is 1. So when it is 1, so this is called the base case. Okay, so this is the base case. Okay, so when this base case is reached, okay, which is 1, okay, so whenever this is reached, it will return 1. So this value will turn 2 into 1. Okay, 2 multiplied by 1. So then this value will get returned over here. So 3 multiplied by 2 multiplied by 1. Okay, now this entire value will get returned over here. So 4 multiplied by 3 multiplied by 2 multiplied by 1. This entire value again will get returned over here, which will be 4 multiplied by 5 multiplied by 4, 3, 2, 1, and then it will get finally returned over here. Okay, so now if we call this function, okay, so factorial, okay, let's say factorial of 5. Okay, so now, and we will print the results. So cout factorial, and let's print and see what happens. Let's print, build and print this. So factorial is 120. Okay, factorial is 120. Okay, so if we give 4, let's check. So factorial is 24. Okay, so this is it. So this is recursion. Actually what is happening is, as I have told you, just a quick recap, calling a function from within itself. So when I am calling this factorial function, okay, so initially it's 4, so 4 is getting passed over here initially, then it will not qualify for this condition, it will come in the else part. Okay, now what it will be, it will be 4 multiplied by factorial, okay, that function, and it will be passing 4 minus 1, which is 3. Okay, so now this entire thing will now, what will happen, this entire thing is there, and now this will get executed. Okay, so what will happen is, it will be 4 multiplied by, now this is getting actually executed. Okay, so it will be 3, as I have told, 3 multiplied by factorial of n minus 1, which is 2. Okay, so what will happen, it will happen 4 multiplied by 3 multiplied by factorial, this will get executed, which is 2. Okay, so now 2, and then it will be fact of 1. Okay, so now what will happen is, it will get like this, 4, 3, 2 and 1. So the moment 1 is returned, this entire thing value is done. So this entire thing value will get calculated and will get returned. Okay, so, and then you are getting the value over here. So okay, so once this is getting returned, if you notice from this image, 1 is getting returned over here, then this entire thing is getting returned over here, and ultimately this return is executed, and then we are getting the final result, which is the value of r. Okay, so this is factorial. Okay, one more example can be Fibonacci series. Okay, so for that, Fibo, let's say, okay, so how Fibonacci series is there, if n equals 1, then return 1, else if n equals 1, then return 1. Okay, else, in the else portion we will return, what is Fibonacci? Fibonacci means, here we have Fibonacci series. Okay, what is Fibonacci series? Fibonacci means something like this. Let's say we want the nth Fibonacci number. Okay, so let's say it will be 0, 1, so 0 plus 1 is 1, so it's like this. Then now 1 plus 1, last two, 1 plus 1, it will be 2, then 2 plus 1, which, what is it, 3. Now 3 plus 2, what is it, 5. Okay, 5 plus 3, what is it, 8. So it's something similar to this. Okay, so if when we say nth Fibonacci number, okay, so we will be getting something like this. Okay, so how do we do this? So return Fibo n minus 1 plus Fibo n minus 2. Okay, and we will be calling this. Okay, but what we will be doing is, we want to print the Fibonacci series, right? So in that case, what we will have to do, we will have to run a for loop. int I equals 0, let's say I less than, what is the Fibonacci number, let's say int n equals, let's say 4. Okay, if n is 4, then it will be n and I plus plus. Inside here we will be calling Fibo and we will pass I. Okay, so now if we run this, let's see what happens. Okay, it won't get printed, we haven't printed that, so we will have to see out this. Okay, so let's save this. So 1 0 1 1 2. Okay, so if we give here 5 or maybe 6, okay, and if we execute it again, we will get 0 1 1 2 3 5. Okay, if we give, let's say 10, okay, so we can print the Fibonacci series. Okay, so how does it work? 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 8 is 13, 13 plus 8 is 21, 21 plus and so forth. Okay, so this is it. Okay, so every time this function Fibonacci is getting called, it is getting passed with this value of I, and then this actually is getting executed. So these are the base case, these are the base case. Okay, so if this value reaches 0 or 1, then it will get returned 0 or 1, else this will get returned. Okay, and the tree goes something like this. See, when 6 is there, then it will be 5 and 4. Okay, if we are passing 6, it will be n minus 1 n minus 2. If you notice, n minus 1 n minus 2. Now this one will get executed like a tree, so 4 and 3. Okay, and this one will get executed like 3 and 2. Okay, this 3 will get 2 and 1, and this. Okay, so this has reached the base case, which is 1 and 0, and this also 1 and 0, and this, see, all the end part is actually 1 and 0. So once this is reached, this will actually execute and then calculate this, and you will ultimately get this result. So each time you are actually getting this result. Okay, so let's say 3 for example. Okay, so this actually value is actually this particular f, this root value. Okay, so you will get that value. So this is it, and you get a Fibonacci series also. So hope you enjoyed this video and learned something from it. So thank you for watching. Bye.